All right. So we are now going to get into math. So, like numbers and everything. So, yay, lucky us. So now that we know how to label a line, how to label a point, how to label a plane, we can now start determining the midpoint and how to find the distance between on lines and how to find the bisector and this, that, and the other, okay? So that's what we're going to do today. So the first thing we're going to do is number lines and segment addition and bisectors. Okay, so the first thing we're going to do is finding a midpoint on the number line. Now, midpoint, think of middle. Okay, so think of middle. Okay, it's the middle point. It splits the line in half. Okay, so segment AB has points at -4 and 9. What is the coordinate of its midpoint? So this right here is something that you will need forever and ever. Okay, this is the midpoint formula. Okay, and M stands for midpoint. Okay, so it says segment AB, so we have segment AB right here. Has endpoints at -4 and 9. So how we're going to model this is we're going to use -4 as A and 9 as B. Okay, so A being -4, we're going to plug in for A, and then 9 for B, and then we're going to divide by 2. So we're going to solve the top first. We're going to solve the top first. So -4 plus 9 is 5. All over 2. And therefore, the midpoint of this, segment is 2.5, or you can leave it in 5.5. Okay, or 2.5. Okay. Example 2, find the coordinate of the midpoint of AB. Okay. So remember, the midpoint is the middle point, and we have our formula, A plus B divided by 2. Okay, so A right here is -3.5. Okay. And then we have B at 3. So we're just going to plug in. -3.5 for A plus 3 all over 2. Remember, we're going to solve the top first. So that leaves us with a -3.5 plus a +3 would leave us with a -0.5 all over 2. Again, you can leave it in this, or you can put it in a decimal. Excuse me. I'm so sorry. I need water. Holy moly. Okay. So, there are 2 ways that you can find this now for this equation. Okay. So, example 3, you'll get into something a little bit different. Okay. Here in example 1 and 2, we found the midpoint. And on this example, it says if the coordinate of the midpoint of segment AB on a number line is 3. So that means that 3 is our midpoint. Okay, and it says that A is at -2, and then we need to find the coordinates of B. So this is how you can solve it graphically, okay, or algebraically. So I'm going to show you how to solve it graphically first. Ooh, I got my voice back. So how you're going to solve it graphically is just you have to make a number line. Okay, so if A is at -2, we're going to put -2 right here. -1, 0, 1, 2, 3, 4, 5, 8. I'm going to hope that that's correct, and I'm going to stop at 8. So I'm labeling my number line. Okay, and I have my midpoint is at 3. So here is my midpoint. My first coordinate, my one of my endpoints is at -2. So that's A. Okay, so how you solve it graphically is just step 1, count from point A to point M. And then your second step is to repeat the count from point M. Okay, so what I mean by that is I'm going to start at one of my endpoints. Okay, I'm going to start at my A, and I'm going to count 1, 2, 3, 4, 5. And from there, from A to M, I moved 5 places. So from M to our last endpoint, which is what we want, I'm going to count 5 units away. So 1, 2, 3, 4, 5. And B should be here. So B should be at 8. Okay. If you like algebra, okay, this is how you solve it algebraically. Okay. Well, remember the midpoint formula up here. M equals A plus B all over 2. Okay. Now we just need to plug in what we know. Well, our midpoint was 3. So I'm going to plug in 3 for M. Our A was at -2. We don't know B, so we're going to leave it blank. And then all over 2. Now what I'm doing is just solving for B. Right here, I'm just going to solve for B. Okay, so how I do that is I'm going to, right now, the whole top part of that fraction is being divided by 2. So we need to do the opposite to move that divided by 2 out of the way. So the opposite of division is multiplication. So I'm going to multiply by 2. And what I do on one side, I have to do on the other. Okay, so I have 3 times 2, which is 6. And I'm left with a -2 plus B on top. Okay, and then B's not by itself yet. So I need to add 2 to both sides. Okay, and I should be left with 8 equals B. So either way, you get the same problem. You get the same answer. Okay. All right. Finding distance on a number line. Okay, on a number line, you can find distance between 2 endpoints by counting, or you can use a formula. Okay, so you can use a formula. Okay, the absolute value of A minus B. Now, these little things right here means the absolute value. And all that means is distance from 0. Your answer should always be positive. Think about it when you're using the GPS. You're driving. When you go a distance, your distance can never be negative. Okay? Your distance can never be negative. So when we're finding distance, you should only get positive answers. Okay? All right. So here is our distance formula. We need to write this down. Okay? All right, where A and B are the endpoints. Okay? All right. So this is going to be very important. When two letters are together like that, okay, when two letters are together like that, that does not mean line PQ, line QR, or line PR. This is why I emphasized when labeling lines that you put the line on top, or you put the ray on top, or you put the line segment on top, because two letters put together with nothing on top of them, no line indication, means find distance. Okay, so this is why you should always put the line above if you're talking about a line. Okay, if you just put two letters together, I'm going to think you're talking about finding distance. Okay, so remember the distance formula is the absolute value of A minus B. A minus B. So let me show you how that works. Okay, I want to find the distance between P and Q. Okay, and in your notes, I want you to just make one number line. Just make one number line because all the points are the same. And then you can put the answers underneath, like our examples. Okay, so I want to find the distance between P and Q. So here's how the distance formula works. I take the absolute value bar. I do one endpoint, which is P, and P is at a negative 3.5 on this one. Okay, I'm subtracting, and I have Q. Okay, and point Q is at negative 2. So anytime I have negative numbers, I always use parentheses to help me organize my numbers, okay? All right, so we have a negative 3.5 subtracting a negative 2, which if you put that in your calculators, you should get a negative 1.5, okay? And remember, the answer is not negative 1.5. You might think you're done, but remember that distance cannot be negative. The absolute value bars are saying how far is negative 1.5 from 0. And it's only 1.5 units. So the distance between P and Q is just 1.5 units. Okay. All right, so here's another way you can do it, okay? You can count. You can count on the number line. So this one I want Q from Q to R. So on the number line, I'm going to start at one of the endpoints. And I jump 1, 2, 3, 4, and a half. So the distance between Q and R is 4.5. Okay? So there's two ways you could have done it. Now, when you're using halves and you're drawing your own number line, it's important to put tick marks so you can know where the halfway mark is when you're trying to just count. When you use the formula, it doesn't matter if you have tick marks or not, okay, because you're not counting. Okay, so I want you to try this, and we'll check it in our bell ringer the next tomorrow. Okay, so you try this example. I want from P and R. Okay. All right. The next thing we're going to go over. the segment addition postulate. The segment addition postulate. So, remember, postulate just means a geometry rule. Just means a rule. And remember, a segment is a part of a line. So, I want you to draw this in your notes, okay? I want you to draw this whole thing that we're about to draw, okay? All right, so I drew just segment with 3 points, okay? So the segment addition postulate says that AB, this little part right here, plus BC equals AC. Okay, so the distance between AB plus the distance between BC equals the whole line segment. Okay, so you'll hear me say a lot, part plus part equals whole. I say this a lot, okay? So part plus part equals whole. All right, practice 1. All right, B is between A and C. AC equals 14 and BC equals 11.4. Find AB. Here is your hint. Always draw a picture. Okay, so I'm going to draw this part right here. It says point B is between point A and C. So I'm going to draw a line segment just like the one up there. So point B is in between A and C. Okay, it says that AC is 14. So this whole segment is 14 units. And then BC is 11.4. Find AB. So I need to know what the value of AB is. So what do we always label unknown distances or parts of an equation? We label it with a variable. Okay, and I'm going to use X. So let's go back to our segment addition postulate. It wants me to find the value of AB. So the way I find AB is I use the part plus part equals whole. So my unknown part, my X, plus my BC, okay, my BC was 11.4 equals my whole, and my whole was 14. And now you just solve. So how do I get X by itself here? I'm going to subtract 11.4. And I should get X equals 2.6 units. Okay, so that means because X equals 2.6 units, that AB is 2.6 units. Okay. All right. All right, so I want you to do practice 2, but I'm going to get you started, okay? You're going to do this at home, so you try, and you'll check it tomorrow morning. Okay, so this is what we're drawing. S is between R and T. So point S is between R and T. And it wants us to find RS. Okay, so I'm going to highlight what you're finding. We're finding RS. Okay, it says that RS is 2x plus 5. ST is 3x minus 2. And RT, our whole, is 33. So don't let the big equations scare you, okay? The first thing you're going to do is draw your picture, always. Okay, and that's what we did. Your second step is to write an equation. Okay, we need to write an equation. Okay, so remember, part plus part equals whole. So the part we want to find, RS, is labeled with 2x plus 5. Okay, so we have 2x plus 5 plus our other part, ST, 3x minus 2, equals our whole, which is 33. Okay, step 3 is you're going to solve for x. Okay, so once you solve for x, you're going to get 1x by itself. Just adding 1x by itself. And then step 4 is you're going to substitute. Okay, and what I mean by that is when you find the value of x, when you're done solving this equation right here, okay, when you're done solving this equation right here, you are going to plug x back in to this equation to actually get the value of RS. Okay, so I want you to try your best on this one, and then we can check it together. All right, a segment bisector. Again, another term that we need to go over. Okay, so a segment bisector. Okay? It's a point, line, ray, segment, or plane that intersects a segment at its midpoint. So when it intersects a segment at its midpoint, that means that it will divide that segment into two congruent parts. So congruent, all congruent means is equal. Okay, equal parts. Okay, so here's the picture that we're using. Okay, it says Y or WY. So it says WY bisects UV at Y. So when it says bisects, that means it cuts it in half. So when it cuts it in half, this segment right here is equal to this segment. They're equal parts. And how you show that they're equal parts is with tick marks. So you'll hear me say this a lot. Those tick marks show congruence. So tick marks show congruence, and just a little dash on this the line. Okay, you'll see this on shapes. Okay, you'll see this on triangles and hexagons and whatever we get to. Okay, so that means that UY is equal to YV. That's what that means. Okay, so let's go to practice 1. If UV, so I'm going to redraw it a very bad way, okay? But if UV is 18, so this whole thing is 18. Okay? Find UY and YV. All right. So we want to find what the value of the parts are. Part plus part equals whole. We have the whole. Okay? Well, remember, uy is equal to yv. We have two congruent parts. So if they're congruent, I can take my whole, okay? I can take my whole and divide it by 2. Okay, well, 18 divided by 2 is 9. So that means that uy equals 9 and yv equals 9 units. Okay. All right. All right, again, okay. I'm going to redraw my picture. And this is sort of how you will solve that last one I let you do on your own. Okay? Like solving and substituting. Okay, solving and substituting. This is kind of an idea of how that goes. Okay, u, y, v. Okay, I drew my most important part. Okay, so uy is 4x minus 3. So from that's from this distance right here. Okay, from this distance, I have, it says yv is x. Okay, so I like to kind of keep everything a little bit. Okay, and it says find uy and uv. Okay, well, let's go back to the segment bisector. Okay, it splits it in half, so it creates two congruent, write this in red, two congruent segments. So what that means is uy is equal to yv. All right, so how I'm going to be able to solve for x, because I need to know x to actually know distance. Okay, so if you see an x, you're probably going to have to solve for it at some point. Okay, so I'm going to plug in the distances I know, the formulas it gives me, the values it gives me for each of those distances. So uy, this distance right here in green, is 4x minus 3. So I put it under, I substitute in for the distance of uy. And then yv is x. It's highlighted in blue. Okay. Now I'm going to solve for x. Okay. So I have an x on both sides. So I need to get an x on one side of the equation. So I'm going to move my 4x over. So I have a negative 4x or minus 4x. So I'm left with a negative 3 on the left side, because these, it gets you 0 on this side for 4x minus 4x. And then I have a negative 3x on my right side, 1x minus 4x. Okay? All right. Am I done? No, I'm not done, because I still have a negative 3 multiplying with my x. So I'm going to divide by negative 3. Okay, well, negative 3 divided by negative 3 is 1 equals x. So now that I know the value of x, so this is where kind of what I was saying up here, okay? I solve for x up here. Now I need to use x and substitute. Okay, that's exactly what we're going to do here. I want to find uy. Okay, well, uy is 4x minus 3. I'm going to plug in my x. So I get 4 times 1 minus 3. 4 times 1 is 4 minus 3. So uy is 1. Okay. All right. Now I want to find UV. Now let's talk about this. Remember that UV is the whole distance. Okay, it's the whole. And we know the values of our parts, okay? So remember, part plus part equals whole. So the green part plus the blue highlighted part equals the whole part. So UV equals UY plus YV. Okay, so all I did was set up an equation that will help me find the value of our whole segment. Okay, our whole segment right here. So I did green part, so let me highlight that for you. UY plus YV equals our whole. Okay, and I'll highlight that in yellow. So now, again, I'm just going to plug in what I know. Well, I found out that UY equals 1. So I'm going to plug in 1 for UY. Well, guess what? They're congruent parts because it was bisected. So that means that YV is also 1. But you also knew that because the value of YV is X and X equals 1. So UV equals 2 units. 1 plus 1. Okay? I hope that's not as confusing as sometimes it sounds, okay? So, there are multiple steps in these, but I promise you can do it. We'll do more practice here soon, all right? Bye.